Good afternoon. Hi, can everyone hear me okay in the back and everything with these mics? Okay, good, thank you. So I'm going to be talking to you today about the new UI system. So my name's Tim Cooper. I work at Unity in Copenhagen, but before that I used to live in Australia. I've been there for 3.5 years now, and I've been working since Unity 3.5 on getting features out to you and helping you however I can. So let's have a look at what we're going to be talking about today. So as I mentioned earlier, I'm a programmer at Unity, and I'm currently one of the lead developers on the UI system, specifically to do with a lot of the low-level core stuff, such as the event system, the messaging system, the Canvas batch code, and that kind of thing. So the things that are sort of more related to performance and memory, and the kind of stuff that really helps the new UI system perform quite well. So what is this new UI thing? If you haven't been aware, Unity has been working on a new UI solution for about over 3 years now. We had many internal versions. Some are more C++, some are more C#. And along the way, we never really felt comfortable with anything we'd come up with. There was always some sort of constraint that we didn't feel was right in the system. So eventually what happened was we decided to start from scratch, and about 2 years ago, we scrapped everything we'd done before and started afresh. So what was the problem with the old UI system that we really wanted to solve with the new one? So the biggest thing was that making UIs in Unity was really difficult. You needed to be a programmer. So if you're an artist or a designer, you couldn't make a UI system. Everything was done in an update loop, so the code was called every single frame, even if you weren't really rendering anything. The code was actually quite ugly because it was an immediate mode UI system, and it was not very configurable in terms of skins and layouts and that kind of thing. And in the end, a lot of the UIs you developed didn't really look very nice unless you put a whole bunch of effort into making them look good. So that's why we decided to come up with a new system. So the solution for this and the problems we wanted to solve were that we wanted a system that was really easy for artists. They could use an inbuilt editor in Unity to drag and drop elements, configure lists, buttons, trigger callbacks, and that kind of thing. We wanted to also make it flexible for programmers, and by that I mean we wanted the system to be very, very open, so you could write your own components, extend existing components, and essentially tailor everything in the system to exactly your game's requirements. In addition to this, this was confounded with the added problem that we needed to make it fast. So we made decisions where we would draw a line between what code would be in C++ and what code would be in C#, so that we had what we feel is the best of both worlds. We'd have a C++ side that was very, very quick, and this is to do with the canvas batching and the rendering and that kind of stuff, and a C# side that was very flexible and easy to extend. In addition to this, a lot of the APIs in Unity historically haven't had the best memory allocation patterns, and we went and extended a lot of the component frameworks to provide no allocation getters and setters and that kind of thing. And by doing this, it means that the UI system as it currently stands is garbage generation free, which means that you won't incur GC hitches by using it. And the final point, which I've sort of covered a little bit, is we wanted it to be open source, so you can do whatever you want with it. And we are releasing the UI system as a fully open source product under the MIT license, which means you can take it and do what you want with it with no restriction, or whatever the MIT license restricts you on, which is very lenient. So how does the UI system work? I'm going to start by asking how many people here have actually had a go at the 4.6 beta. So that's probably about half, maybe, I would guess. Is anyone here completely unfamiliar with it? Okay, there's a few. Okay, so what we're going to do is I'm going to give you a quick high-level overview of the UI system, and this is going to be a bit of an interactive demo. And then after we've covered this, I'm going to go into a very deep sort of analysis and discussion on how the new system works and how to extend it. So this isn't the most beginner talk for the UI system. It's more designed for people who've been playing with the UI a bit and really want to understand how it works internally. But of course, we'll cover the top level stuff to begin with, just so you can have an understanding. So in concept, the UI is designed based on a canvas. You add elements to this canvas and they render in the hierarchy order from back to front. The canvas can exist as a screen overlay, which means it is essentially like a standard 2D game heads-up display, or it can exist as a canvas that you put in the world. And by this, I mean you can do things like have an interactive computer terminal or a keypad or something like that that lives in your game. And you can choose to have or not to have interaction on this element depending on what you want. In addition to this, we provide an array of layout tools, such as grid layouts, flow layouts, or you can use auto layout tools to just have your things positioned and stick to the edges of the screen. Outside of this, there's a whole event system which controls essentially what we call the business logic of the application of the UI. So things respond to touches and receives events from the touch module or the pointer module if you're using a mouse. And this is sort of handling things like mouse enter, mouse exit, and abstracting it away into a sort of a nicer framework. So we've covered this already in prior talks, but let's just jump across to Unity and I can show you a quick example of how the system works. So what we're going to do is we're just going to unfull screen this. We're going to create a new scene. And from the game object menu, you'll see that there is now a section for UI. These are sort of the basic high-level components we're providing out of the box in 4.6. And that includes things like buttons, text elements, panels, sliders, and scroll bars. We're going to start by just creating an image. Now, what an image is it essentially is just that. It takes a sprite reference, as you can see here, which is from the existing 2D Unity toolkit stuff. And you can pop up and just select what you want it to be. Let's pick a clearer one. So like this. So this is now using the sprite we saw earlier. One thing you'll notice is we actually have a new tool in Unity 4.6, which we call the Rect Transform tool. This isn't just for UI elements. All the 2D components we have and also 3D components can be modified using this. It essentially specifies the position and the size of the object in rect space. If you have a look here on the right in the inspector, you'll see that there's a scale. When we modify the rect transform, you'll notice we don't actually modify the scale of the object. Instead, what we're modifying is the width and height. So this is a new component that inherits from transform and adds this additional rect handling functionality. And this is really useful for UIs because you don't tend to want to use scale to represent what happens with your UI, especially when you're using fixed width borders and things like this. Scale still works, and if we modify scale here, what you'll see is the UI it actually does then squish and stretch. So by using the scale, you can modify the borders if you want. But let's just turn that back to 1. Now, we break up the components that we have in the UI into a number of different types conceptually. The 3 we have at a conceptual level, we have layout components, such as grid layouts, flow layouts, horizontal groups, and vertical groups. We have interaction elements, and this consists of things like buttons and toggles. And we have drawing components, which are images or text or something custom you may write yourself. When we create a game object from the game object menu, you'll actually see that what we do is we tend to generate a game object or a series of game objects that have a number of these components. And by combining these components is how we add functionality. So what we'll quickly do now is we'll turn this sprite that we have in the scene here into a button. The first thing that we'll do is we'll add a text element to the button. It's a bit hard to reach from up here. And we'll make that text element a child of the image. If you have a look here, we have this tool, and this is the UI anchoring tool, which we developed quite a while ago. And what it does is it specifies how this object lives in the scene in relation to its parent. So if I click here, for example, we have a top left alignment, we have a bottom right alignment, but we also specify things like stretching. So what we can do, and what we want to do in this case, is we want this element to resize based on its parent. We can then go and look at the text and make the text live in the middle of the button, and we'll just turn the font size up a little bit so it looks quite nice. We'll just type button bug. Yes, anyway. So this is what we have now. We've added a button component to the, we've added a text component, but we don't have any button functionality. So if we enter play mode, what you'll see happen is nothing at all, really. We'll mouse over, nothing's happening. So what we do now is we're going to add an interaction component to here. We'll just rename this to the base element of type button. And what this does is it allows you to specify button functionality. So for example, we have different modes by default for transitioning. So we have color tint, sprite swap, and animation out of the box. Sprite swap and color tint are what we consider to be the two most common modes of a button working. But with animation, you can do anything, such as you can do a sprite swap and a color tint simultaneously. It just means you need to be familiar with the Unity animation workflows. So what we'll do now is we'll just quickly modify this button to have some different colors for different events that are occurring. And here we go. And then we'll enter play mode. And what you'll see happen is when we mouse over this button, we get the highlight color, and then we press, we get the press color. So this is a high-level look at how you can construct things using the components we have inbuilt into the UI system. But these components are also very extendable, and you can do whatever you want with them based on the source code. The next thing I'll just quickly point out is when we created this original button, we actually added an event system to the scene. And what the event system is responsible for is essentially managing events that occur, such as mouse movement and presses and that kind of thing. The one we have here is supporting standalone, which is controllers and mouse and keyboard, and it also supports touch. So we've added two components to add this functionality. But let's jump back to the actual presentation, and we'll start going a little bit more in depth into how the UI system works. So what we're going to do is we're going to do something a little more interesting. When we started designing the UI system, we realized that there's a lot of things in Unity that, whilst they work, they're not the best programming practices in this day and age. And maybe when Unity was first written 10 years ago, they were okay, but the expectations now are much higher. So if anyone here has used Unity and used GameObject.sendMessage before, you're probably familiar with just how not robust it is at times. So what we're going to do is I'm going to cover the new messaging system we've developed for the UI, which is not just for the UI, it's completely generic and can apply to anything. And then we're going to cover how to develop a custom input module for the UI. And by this I mean we provide ones out of the box for devices such as all touch devices and consoles and that kind of thing. But we don't provide one, for example, for Connect currently and a few other things. And this will show you how you can write your own input module and have it work on these platforms. So the messaging system. So as I mentioned before, Unity currently recommends a lot of the time using sendMessage. Now there are issues with this. It uses strings to match function names, which makes it very hard to refactor. Even a lot of the automated refactoring tools like ReSharper, whilst they'll work, it just feels really dirty having to refactor strings. And it's excessively loosely coupled. And whilst I'm a big fan of loose coupling, sometimes you want a little bit more rigidity in the bindings of how the caller and the callee relate to one another. So what we did was we developed a new system for messaging for the UI. It uses interfaces to bind functions, and messages are looked up dynamically and dispatched dynamically to valid receivers. It's still loosely coupled in the fact that you don't need to have a concrete reference to a receiver when you're issuing the event. But it's much more rigid in the fact that you can guarantee, it's much more rigid in the fact that it will refactor nicely, and it's super robust in that way. So let's have a look at how it works. So we have here we'll see this example a bit later on in the project, but we have a interface called the iTerminal Success Handler. And what this does is when you enter a successful PIN in a key code, this function will be called. So our event system, to do this, you inherit off the iEvent system handler and have your successful call, and you just have a function prototype there for it. And then you create a binding code, And what this does is it just allows, this gets used as a functor later to map the caller to the callee. You may think that looking at this, there's a little bit of extra cruft here, and you can remove it. But the idea with this is that you could have your interface have 4 or 5 different functions, and then what this does is it maps the function, the desired function call to the interface. This gets used as a function pointer, as you'll see. Now, the third step is you just inherit off this interface on your mono behavior. So as you can see here, we have implemented the function. And then it's just as simple as calling a helper function on the event system. And what that does is it looks up on the game object which components have this interface on them, and then we'll execute them as you desire. So it can take custom event data, as you see at the bottom. This is just taking a base event data currently, so it's not super important. It takes the function to execute as a function pointer. So as you see there, there's terminal events.execute. And then you specify the target as a game object. And there's versions of this function for things like execute in hierarchy, execute in children, execute in parents, and that kind of thing. So we provide some nice simple overloads for you. Or you can just, this example just executes on the one game object that's given. And one other thing with this is all these things are allocation free and are quite fast in terms of performance, even on console, even on mobile and IoT platforms, which is nice. So let's have a quick look at a messaging example and one in practice and how you would set this up. So I'm just going to give you a quick rundown of a simple application we have here. So this is like a pin code terminal, and when you enter the pin code, we want something to happen. Now let's just see. We'll enter play mode, and we'll start typing on the pin, and you'll see that the numbers pop up. And when you click enter, it doesn't unlock because we don't know the pin. And you can clear like so, but I've forgotten the pin, so I'm just going to have a quick look at what it was. It's not my bank card number. So the pin is 2547, so let's enter that. Oops, clear. And then we enter, and if you can see at the bottom of the screen here, we have a pin entered valid. Now, that's just a little debug, because this is a simple example. This has just got the logic for how the pin code works. It's not super exciting in terms of the event system or anything. What is interesting is we have the process call here, and when the processing is complete, we just debug log. Now, this isn't using the new messaging system. It's just an example showing what we are going to start with to use the new messaging system from. So let's jump back to the application here, and we'll open up the second one. Now, we have the same thing, except we have just a UI element here with nothing written in it. And when we enter play mode, we'll just show you how it works. 2, 5, 4, 7. And it pops up saying pin correct. Now, what we have changed in this example is instead of just debugging, logging something, we're using the event system to call an execute handler on the iTerminal success interface. So this means that any components in the target game object that implement this interface will receive the call as we bind it here. If we have a look at the actual top of this, you can see that we have the interface defined like so. This is a really generic way to bind events in Unity and send messages to things. And it's actually what the new UI system is built off from the ground up. We use this generic messaging system everywhere because we don't necessarily know what can receive or not receive events in a nice way. So, actually, one other thing I'll just quickly show you. This is related to something else in the UI, is that if you have a look here on these buttons, we're using this on-click delegate to do the callback. This is our system that we use in the new UI to allow artists and designers to quickly hook up events to their elements. So for example, as you can see here, we have a call, and then you can say, on click, I want to, on the camera, and then you can select which function you wish to call. So we could toggle HDR, for example, or toggle isometric mode or anything we want just by hooking it up there in the UI. It's a simple form of visual programming. What it does is it allows us to allows the programmers still to have control currently on what gets called, yet lets artists hook up the function that gets invoked. Okay, so let's jump back to here. Oops. Okay, so that's how the new eventing and messaging works in Unity 4.6. Let's have a look at how we've implemented this and how all the components in the UI system hook together and actually work, because this is where the interesting and complexity of the UI system comes through. So what bits exist in the UI system? We have the event system component itself, which is essentially an event system manager. And this delegates a lot of the work to other components that will live in your scene. One of these components, or you can have many of them, are known as raycasters. What their responsibility is for is when you click or do a mouse action, their job is to return what has been clicked on or moused on. Out of the box, we support a few different types of raycasters. We support the UI raycaster, or the graphics raycaster as we call it. So if you select here, you'll see we have one. And what this is used for is raycasting against canvases to figure out what you've clicked on. Other ones we support out of the box are 2D raycasters and 3D raycasters. And this means that you can use these for having the event system and the input modules work with any part of your game. So you could do an RTS game where you, when you click on a 3D object in the world, it receives the events that you configure for it. The next one we have is input modules. And now the input modules are essentially the platform-specific or the input type-specific input into the event system. And this is where all of the business logic occurs, such as handling mouse overs and mouse outs and that kind of thing. And we'll have a look at that in a moment. And the fourth one is the components, which I mentioned earlier, such as the interaction components, the drawing components, and so on. So the Event System Manager is responsible for handling state. It manages things like the selected object, some global settings, such as touch threshold and things like this. And it also manages which of the input modules is currently configured and activated. The input module, as I mentioned earlier, it handles game or platform-specific input settings. So if you're using touch or controller or FPS modes, we only currently allow one input module to be used at a time. You could change this if you wanted to with the source code. And it sends events like pointer enter and pointer exit. Yep. And raycasters are normally used for figuring out where the cursor is or what you're trying to look at. Yes. And we've covered that already. Okay, so that's not up to questions yet, but we have more demo. Because what we're going to do is we're going to go through and we're going to create a custom input module that can be used for FPS games. So as you've seen with the terminal before, let's have a look. So we start with this one, terminal 3. So what we have here is we have a 3D game. Now this 3D game is just really simple. We have a terminal in the scene here. And as we look around, you can see this is just the robot lab that we have in Unity. But there's and we've made our keypad attached to the wall here. So this is using a world space UI, as you can see in the world. Now what we will do is as we walk around, you'll notice that we can mouse over and we can have the button selected. But this isn't really super nice because a lot of the time in an FPS game, you don't have a cursor. You're using the view from the camera to handle what gets clicked on, what doesn't get clicked on. So it's not super nice, but we can still interact with it like so. What we really need in this example is we need a custom input module that can be used for handling the camera as the main location for where raycasts should exist. So let's start looking at how we would do this. Now, let's just see if I can find the source code. So what we have is we have this module here, which we've created, called the FPS input module. Now, the FPS input module extends off one of the inbuilt modules we have in the UI system called the pointer input module. And what the pointer input module is it's a module that is used to simulate, to handle pointers. So the touch input module and the standalone input module that we have both inherit off this element. Now, as you can see, because it's using object-oriented programming, we have an override call to the activate module, which is what happens when the module gets turned on, and a call to deactivate module, which is what gets called when the module gets superseded by a different one. Then we have a process function, which is where you can put all your custom processing data. And this is where things start to get interesting. So what we do in this situation is we want to create a raycast that comes from the camera, but raycast against everything in the scene where there's a raycast module configured for it. So this is actually quite simple to do. In the base module, which I'll just open up now, hang on a sec. So the pointer input module provides a whole bunch of functionality with regards to pointing. We have a cache of pointer events. This is things like a pointer event in our system is when a mouse event or a pointer event occurs. We cache it so you can use it between frames, such as handling when a pointer is clicked and a pointer is let go. We want to know that it's the same thing. But we have this call here to, where was it? It was in get mouse pointer event data. And what this does is it populates the data from the current mouse position and puts it into the pointer structure. So what we do is hang on, I think I actually put a copy of it in the other class, strangely enough. Yes, sorry, there we are. So what this does is it generates a mouse state for us relating to where the mouse is on the screen. We actually override this in this case to hard code the position to be the middle of the screen. Because what we're doing now is with the FPS module, we're assuming that the mouse or the raycast source is always from the center of the screen. We then delegate to the event system to call raycast all with the given data. And what this does is it says, event system, figure out which raycast modules are present. It has a cache of them. And then raycast using this current location. This allows us to do things like have multi-touch because we can use different pointers to cast at separate times. So you can have multiple events occurring simultaneously. And then from that raycast information, we construct the pointer event data. I didn't mean to close that actually, silly. Once we have that data constructed, we can figure out what's happening with the left button, like so for example, if someone's clicking or releasing. And then we can process these, such as processing a press, processing a move, or processing a drag event. And what happens is, this is where the business logic occurs, and this is where the input module really starts to become interesting. So let's have a look at what happens in process mouse press. Next. So because this is a module that is very specific to FPS, the only things we really want to handle are if the cursor has, if you've looked over something, looked off something, or clicked the button. So we can use the data structures we have. These are all documented in the UI documentation to figure out what should happen. So if we've pressed the button this frame, we actually want to mark the pointer as eligible for click. We haven't started a drag yet, so we mark dragging as false and this kind of thing. Now we start to look at how the input modules tie in with the messaging you saw earlier. So what we want to do is we want to search for the control that we've clicked on to receive the press event and handle and then figure out if we should do a click. So what we do is we call execute the pointed down handler. And what this will do is it will look at the currently moused over game object and then call the pointed down handler. This is one we provide out of the box in the system. And then we cache the element to see if there's a valid thing to receive a click later on. We then have some handling here for double clicking and the like. So if you wanted to write a game where there was no double clicking, you wouldn't need this code, or you could write extra code for other types of clicks. Another thing you could actually choose to do if you wanted is if you detected a double click here, send a specific double click event rather than what we're doing, which is just increasing the click count and then letting the handling be done in the UI element itself. And then there's also handling for what happens when you release the button this frame. And in this case, we send events like pointer up and pointer exit. And if you've got a drag handler, we do dragging at this stage. So if we have a look at how this is now set up, you'll see that on the terminal, once again, we have the same code. But this time, when we walk up to the terminal, you'll see that it's linked directly to where the camera was looking from, rather than being hooked up to the mouse. Using this kind of system, it's very easy to write controls that work with, say, the Oculus Rift or the Leap Motion and that kind of thing. We have a user, and what they're doing for the Oculus Rift, for example, is making a virtual camera that lives between the two Oculus cameras and using that for their raycast location. People are simulating input using the Leap Motion, I believe it is as well. And there's been some really interesting things I've seen with one of the finger touch gloves. I'm not sure what they're actually called, where people have been using the virtual representation of the hand to type in to keep virtual keypads in their games and slide things up and down. And that is using custom input modules for this handling. So the way the system is designed now is it works very well for what we consider to be the majority of applications. But if you want to do something more interesting or more custom, then you can just grab the source code and go nuts and create your own thing. So we are not quite up to questions yet either, because we're going to go through some more things. And what I was going to ask is there anyone who's been using the UI system recently has in regards to something they really wish to understand and how it works internally, rather than have a question directly like that? No? Yes?
So one of the things I noticed with scaling objects,
Mm-hmm.
when you have a component underneath, it's like an image inside of an image. If you pair them up so that when you scale them and the second image with the parent scale down correctly to the way its parent scales, how do you manage to scale it correctly to its parent, which doesn't actually fill the same space as its parent? So like if it's a small image inside of a large image.
Okay, yeah, I can show you how to do that. Yeah. So we have, are you familiar with the anchoring we use?
Yes.
Yes. So have you tried, let's just do this quickly. Okay, we'll just put an image on here. That one. And so you have a child of this, which is like so. So it's smaller, and you want it to scale with the parent. Oh. So at the moment it's set to scale relative to the parent, like so. So the percentage of space, this is going to set the number of pixels, but it's not going to set the relative size. What you want to do is you want to drag these out to, say, here. And then what that'll do, it's not quite 100% accurate there, is that'll keep the relative size to the parent. Was that your question?
Yeah, basically, yeah.
Yeah, cool. Okay. I'm sort of looking for something internal, like does anyone want to know how, say, a button works, for example, or something that we can really get into? Yes?
Can you show us how to create a GUI in world space?
Yeah, of course. So creating a GUI in world space is a interesting thing. So what we'll do is we'll start with this UI here. Now, this is the pin terminal you saw earlier, and it's on a canvas. If we have a look at the canvas, you'll see that the canvas currently exists in screen space. And what this means is that it's just going to be overlaid over the top of the scene at the very end of rendering. But world space canvases work slightly different. They get inserted into the normal rendering pipeline, and they get rendered in the scene. And the first thing you need to do when you're trying to make a world space canvas is just convert it to world mode. And what you'll see happen is it'll live here, but we can't see it from the camera because the camera isn't pointing at it anymore because it's now living in the world. So the first thing we'll do is we'll just grab the camera and we'll go align with view. Yep. And if we just change this out of 2D mode, you'll see that the camera is well away from the UI. There we are. You can see the UI up here. So this UI is now rendered in the world via every camera that has a culling mask set up to handle it. One thing that is a bit confusing that you'll notice is this is actually really, really large. It has a width of 980 and a height of 550. And the reason that the canvases work this way is that 1 pixel in canvas space equals 1 world unit in Unity. And so that's why it's quite large. So what you want to do is when you have this in your application and want to put it somewhere, let's say you wanted to make this into a billboard or something like this, say some futuristic sci-fi animated billboard, is you need to position it so we can rotate it however we want. Let's actually create a billboard for it. Where are we? 3D. Cube. So I mean, if you look at it compared to the size of the cube, right, it's a little bit large. So what we're going to do is we're just going to scale this up a tiny bit, not too much, because we don't actually want to do it that way. But instead of doing that, what we're going to do is we're going to grab this canvas. And now this is when you wish to use scaling. You want to bring the canvas down to a size that is nice for your thing. And just line it up on the billboard like so. So when you're working with world canvases, it is actually recommended to use scaling, but you scale the canvas, not the individual elements. And so this will now work if we had a FPS controller and walked around, we could go up and press buttons. And that's exactly what I did for this demo here. So I simply added the FPS input module that you saw, and then just dropped it in, and now you can walk around and use this world canvas, and it works with the UI system. So you can do lots of interesting mini games or something. Yes?
When you're rendering in screen space, how do you handle different screen pixel densities? We're thinking of the retina screen in the back there's now 3 size screens.
That's true. So there's two sort of two sides to this question. Are you interested more in how do you handle layout, or how do you handle similar like aspect ratios just at different resolutions?
Mostly layout, because I've had doing business where it's expressing pixels and that won't be appropriate.
Yeah, okay. So the first thing we have in that regards is, I'll just open a screen space scene because it's a little bit easier to explain it in that context, is on the canvas, the first thing you'll notice is we have this component here called the canvas scaler. Now what the canvas, can you see that okay, or I don't know if I can zoom in. No. And what the canvas scaler does is when you construct your UI, you can construct it with a reference resolution, and as the aspect ratio changes, or you move on to devices with more or less pixels, what you can do is you can have the the layout bias either towards matching the height or the width of the different aspect ratio. And we find that like sort of a 0.5 value works for a lot of resolutions, most devices we've tried on. And it sort of will just move things nicely if you've laid out your elements in a sort of a scalable and nice way. One cool thing about it is we recently improved this so that with the canvas scaling, it'll actually also resize your text correctly in a very nice way so that text should remain pixel perfect on any given resolution. Yep.
Is that in the latest beta?
Yes, it should be in beta 21, which came out a few days ago, because that's what I've got here. Yeah, we had two components before. We had reference resolution and physical resolution. What this does is it combines the two, and you can configure how you want it to work. It's a best of both worlds component. And if you upgrade a beta 20 project into beta 21, it should just add this and copy the settings across, I think. Okay, so I'm going to have a quick talk now, I guess, about how our internal component model works with regards to sending events. So as you saw earlier in the presentation, we had this module, and what it does is it sends events such as point-to-click handler and point-to-enter and point-to-exit events. What we have is we have this class, this thing, event interfaces. And what this is this is what all the eventing in the UI system is built off. We have pointer, enter, pointer, exit, pointer down handlers and similar. We have drag handlers, scroll handlers, select handlers and things like this. And these are the events that out of the box, the UI system components that we have will send to you. You can write your own input module and send any custom event you want because it all uses the generic messaging system. But these are the ones that we feel cover, I guess, the majority of simple use cases. Some extensions for this that we'd probably plan in the future are things like pinch gestures and rotate gestures and things like that to map more to touch devices and things like that. But they would obviously only be sent by a touch input module that would support them. So what happens is when we do things in the UI system, say mouse enter and mouse exit, the input modules send these events to the components. We know via the raycaster which element we're over, so if we're over a button or if we're over a scroll view, for example. But the components themselves are written in a very generic way. Oops, that's the wrong button. That's the old button. So what we have here is we have a button, and as you can see, it inherits from one of our internal classes called selectable, which is just part of our UI framework that's documented. But it has an extra handler for iPoint2Click and iSubmit. And what happens is it's really simple. All we do is we implement those interfaces, and because it's working via the event system, if you receive a point-to-click event from the input module, we call press, or if we receive a submit, we call press as well, and then do some internal state transition handling. Now, one of the great things about this is that our components are incredibly separated from the actual modules and handling themselves. Like they implement the interfaces, but you can call this stuff without needing a custom input module, which means you can do things like automate button presses and things like that, and do a lot of really nice, like say for example, test automation, which is something we're doing internally now based on the UI system. So we can test the event systems and the input modules and the raycasters and the components all in isolation and have them combine in a nice way. And so, yeah, as you can see, we did this so that the system would be really extensible and very easy to modify and change however you felt like doing. So I think we'll actually hand over to questions now, unless anyone has anything. Yes?
The pointer event data that gets passed in with the function that handles the events.
Yep.
Does that contain a reference to its sender, as in, say, the image or button, whatever it is?
So do you mean, there's two separate things here. Do you mean the callback that is living on the, like the delegate you hook up via UI?
You set up a callback on a script.
So,
I've seen a pointer event data.
so you mean, for example, where's a good one? Where was button? So you mean here, for example?
Yeah, that one, pointer click.
Yep.
Does the event data contain the sender?
So
Or do you have to
this is the sender. Like, this is the thing that's received
If
the...
it was on a different game object.
Well, then you couldn't receive the event because the event will only be received by the game object you click on.
Okay.
Are you...
So you can set up an event trigger component that can send
Okay,
it to something
yep,
else.
I see what you're saying.
And I've tried to do that before, but you can't get the sender.
Yep, so what we can do, I'll just quickly create a new project or new scene to show you, is if we... So you mean, when you have this one configured, right? So what we're doing is we're using a new part of the UI system, or the Unity, called the Unity events. And what they do is they allow sort of user interface hooking up of events. And this example, what happens is we have this on-click thing, which is a button-clicked event, and that will delegate the call from the button to whatever's hooked up to it. So if you have a look, we just call this, we call the invoke on that with no arguments. This is because we didn't want to have out of the box a concept of like we don't want people to care about what button was clicked so much as we want them to care about the event occurring. But it is possible to do. It's just not something we super expose. So in this example, what you could do is we'll add a new script and we'll call it like this. We'll edit this script and we'll add a, so what do we want to do? A public void button pressed game object like this, and then we'll go to here and we will add a new callback here for when the button's pressed, and we'll select this one, and you'll see here. Oh, here we are, sorry. Did I save that script?
You need to rename the method.
Yeah, it's the constructor's name.
Oh, thank you. And there we are. And then what you can do is you can put the game object in there that sends the message, and then that will arrive as like that. Another way you can do it is you can also do a dynamic delegate, which you bind on the onEnable as opposed to this way. But yes, it is possible to do. It's just, we feel that like it's not normally necessary to know what sent an event. Like,
So you would rather have individual scripts on, say, each custom button or something, rather than one that takes events from
well,
10 buttons?
what is a scenario that you think where you need to know the button, the actual game object
Just
button
if
that pressed
if
it?
you had a UI screen script and that was on a game object that
Mm-hmm.
had, say, 10 buttons as its children,
Mm-hmm.
and you just wanted all those buttons to send the event to the parent rather than having a script on each one of those buttons.
Oh, in that case, I would have one function that does it and then bind that function. Like, yeah. Because you still need a function to bind to, so I'll just have the function do that logic, personally, but yeah. Okay, any other questions? Yes?
Are you planning to include any more complex controls into the UI as well, like response, combo blocks, standard stuff like that?
Yes, but not for the first release. We were trying to spend as much time as we could sort of really nailing how the framework kind of worked so that we'd have like a really solid foundation to build off over the next few years.
Can you let us know what is your estimation about the first release time?
Soon?
When is the best time to move towards the new UI? Because you have an application, you invested a lot in UI, in other components. Now we expect to move on with that, so we do that.
Well, I mean, it depends what you're after. If you're really after a lot of these components we won't be shipping in the first release, then it may not be the solution you want right now unless you want to write your own list box or combo box, for example, which is quite relatively easy to do in the system. But if you want to just have what's there now, it's probably getting towards a good time to switch, I would say. Yes?
Is there any sort of management of styles? So if you want to change the look of a button across the board?
Okay, so in Unity 4, there's not, but in Unity 5, they're doing work at the moment on things like HD SD Atlas switching, and that's going to be based off some package naming convention stuff, which I'm not quite sure of the details of. But when that comes, we'll be using the same system for style management, but we won't have that for all just yet. Yes?
What about text formatting, colouring?
Yes. Yeah, so Unity currently has rich text support on their UI elements. Oh, sorry, just in the font support in Unity itself. So, for example, we could go red and do that, for example. We don't have a few things we want in there, like hyperlink support out of the box, but we support, there's a list of tags in the documentation, even from before 4.6. One thing we actually plan to do is we're going to, at some stage, completely rewrite font support in Unity.
So can you do multiple size fonts within that?
Yes. Yeah, you can do, say...
Can you write your own tag?
No, you cannot, which is something which we want to address. Yeah. There we go. Sorry, behind you, yes?
With regard to the text scaling, is that supposed to maintain, which is best, does it try to maintain the size of the text despite the screen being scaled, or will it scale the text to shrink or expand based on it?
So it depends if you're using a canvas scaler or not. So what the canvas scaler element does is it tries to maintain the font size with regards to scaling up. So as the canvas gets bigger, the font size will grow because it's assuming the canvas is being scaled on a device with, say, Retina support. Whereas if you're not using the canvas scaler element, your elements may increase in size depending on how you've laid them out, but the font will stay the same size because we don't consider the scale. The scale's still 1 in terms of what the canvas thinks. Yes?
So does that mean it will reflow text?
Yes, it will.
Is there a way to configure draw order outside of hierarchy? For example, like drop down lists or tooltips or anything like that?
Yes, there is. It's not the most user-friendly thing at the moment, but it's supported. So if you have a look at a canvas here, for example, we have exposed on it the sort order of the canvas. And so if you had, say, a drop-down list you wanted to be rendered after everything else, you could put that on a new canvas and then have the sort order be higher.
So, for example, like a child element, you could have it like a child.
Yeah, you can use a nested canvas and do it that way. Yeah, it's an interesting way in that regard, but it does work. I don't think it's quite user-friendly enough yet, but I don't think we'll be fixing it like super nicely yet. Yes?
With like the auto layout systems like grid or the vertical group,
Mm-hmm.
if you get up to the stage where you've got like thousands of items, particularly on mobile, what's going to be the biggest bottleneck there? And is it worth coming up with a pooling system to...
If you are having thousands of items, I would recommend having a polling system for that. We don't have any callbacks yet for when something leaves or enters a group. It's something we will consider adding, but we're not quite at that stage yet. Most people that I've seen who are using something this in practice, they've developed their own sort of ad hoc pooling solution for elements in a list. Yeah. There was one question at the very back here.
You mentioned that you're going to have a look at rewriting the font system. Does that mean that will that include dynamic font support on mobile? That works both in screen space and roll space?
Oh, we already have dynamic font support on mobiles.
Yeah, but when you do the current support still renders an
Yes. Oh, you mean rendering vector graphics directly on the GPU? Probably not, because we wanted to move towards a solution where we're probably heavily leveraging something like SDF, so we can get a bit more sort of effects and sort of not have to regenerate the atlases as much. Yes? Not out of the box in the first version. It's on our roadmap for the future. Localization is relatively easy to add in a sort of an ad hoc way, but we haven't got a solution that we think scales to every kind of project, which is why we haven't done it yet. Yes?
Is there proper support font kerning?
Yes, so we take the kerning information from the font data itself. We don't allow you to specify custom kerning. If you want to do that, I guess you can edit the font data itself and change the kerning. One thing we want to do is actually provide the ability to, I guess, extend or like slightly modify kerning via the UI if you want things to be slightly further apart, but we don't have that at the moment. Okay, yes?
Let's say you have 100 enemies in a scene and you want to put a health bar above each of them.
Yep.
Would you use an individual canvas for each, and does that have performance implications, or is there a way to batch them as a single canvas, or is that not what you recommend?
You can easily put that on one canvas. The best way I would say to do that is you add one canvas, and then you create your health bars or however they live, and then in a late update function have them reference the enemy that they are above and then just move them into screen space that way.
And that's much more efficient than...
I would think so. What I've seen before is people use, instead of having a late update per character, they would have like a health bar manager that just went and did all of them in one go. And if you're doing something like that, pixel perfect on the canvas is probably not the best idea because it involves more sub-calculations. Yep, any other questions? Oh, yes, I'll go right, then left.
Are there any plans to accept early plans to send this to the editor?
I have some ideas on how to do it, but at the moment it's very much tied to the like the Unity runtime loop. So not as of yet, maybe at some stage, but IM GUI mode or immediate GUI is like quite good for most UI things, for most sort of editor UI things like this. Yep. Okay.
Does this support rendering 3D game objects in this game?
You can do it. It's not very nice, and we're going to be improving it in the future.
When a slider calls something in the event function, say a function that takes in a float,
Yep.
can you pass the current value of the slider as an argument?
Yes. So the slider is inbuilt to do that. So if you have a look at the, let's have a look, UI slider. So if you have a look at the callback here, it takes a float as the argument or a single in .NET terms. Let's see what's something I can hook it up to. The camera, I can use the FOV on the camera. So if we go here and go, so if you have a look, there's two modes. There's dynamic at the top and there's static here. What the static section does is it allows you to pass through a custom value that is always that custom value. Whereas what the dynamic one does is it passes through the current value of the slider. So I could change here, for example, the slider here. Where are we? And what this will do is it'll just change the field of view of the camera. So the field of view of the camera is probably a really weird number now. Yeah, it's that. So it was linked up to there. Is there any final questions before we get out of here, or? No? Okay, we'll be doing a roadmap talk later today. We'll be talking a bit about some of the stuff we're going to be doing in the UI in the future. And I'll be around, so feel free to ask me questions. Thank you.